Timeless concepts from Physics Helpline. In this video tutorial, we will discuss a multiple choice question taken from JEE Main exam of 2023. The question is about a series parallel network of resistors connected to a cell. We are required to find the current through given resistances of the network. Read the question carefully. The network is given. As shown in the figure, a network of resistors is connected to a battery of 24 volts with an internal resistance of 3 ohms. The currents through the resistances R4 and R5, so R4 and R5 are I4 and I5 respectively. The values of I4 and I5 are. The options are given in the question. We are required to find the correct option. Now for the solution. Let us first find the total resistance of the series parallel network of resistances. Now we have named the critical points A, B, C, D and E for evaluation of the total resistance of the network. And there is this internal resistance 3 ohms also. Resistance between points A and B is represented by RAB. We have between A and B, we have got two resistance 2 ohms and 2 ohms in parallel. Therefore, the resultant of these two 2 ohms in parallel is equal to 1 ohm. Between B and C, there is only one resistance RBC, which is equal to 2 ohms. Between point C and D, we have got two resistances of 20 ohms and 5 ohms in parallel. Therefore, RCD is equal to 20 into 5 divided by 20 plus 5. 20 into 5 is 100, 20 plus 5 is 25. This is equal to 4 ohms. RCD is equal to 4 ohms. Between points D and E, there is only one resistance. Therefore, we can write RDE is equal to 2 ohms. Therefore, total network resistance R is equal to RAB, that is 1 ohm, plus RCD, that is 4 ohms, RBC is equal to 2 ohms, plus RCD is equal to 4 ohms, plus RDE is equal to 2 ohms, and internal resistance is equal to 3 ohms, which gives us 1 plus 2, 3, plus 4, 7, 9, 3, 12 is equal to 12 ohms is the total resistance of the network. And EMF of the cell is given by E is equal to 24 volts. Therefore, total current drawn from the cell, I, total current, is equal to E, that is 24, divided by total resistance, this is 12, which is equal to 2 amperes, is the total current drawn from the cell. Now at point C in the circuit, the current flowing from B to C is 2 amperes here. Now, this 2 ampere is divided between the two branches. Therefore, the sum of these two currents, I4 and I5, should be equal to 2 amperes. So we can write I4 plus I5 is equal to 2 amperes. We mark this equation as equation 1. Now voltage between C and D, potential difference between C and D. Let us write VCD is equal to I4 into R4, I4 into R4. R4 is 20. So we can write 20I4, which will be equal to 5I5. I5 into R5, and R5 is equal to 5 ohms, therefore 5 into I5. Now this one simplification gives us I4, I5 is equal to 20 by 5 into I4. That is 20 by 5 is equal to 4I4. I5 is equal to 4I4. So this will mark this as equation 2. So we have got two relations in I4, I5, and here also I4, I5, the equations 1 and 2. From this we can solve. Putting the value of I5 from equation 2 in equation 1, we get equation 1 implies I4 plus 4I4, that is 5I4. Let us write it cleanly. 5I4 is equal to 2 amperes, which implies I4 is equal to 2 by 5 amperes. Which implies I5 is equal to 4I4, that is 4 into 2 is equal to 8 divided by 5 amperes, which is the answer to the question. Therefore, the correct option is 1. This one is the correct option. This completes the answer to the question. Thanks for watching.